In this tutorial, I will demonstrate the activation-by-personalisation method. I assume you have watched tutorial 22, and based on what I have done in tutorial 22, I will continue where I left off in that video. Make sure a LoRa gateway is in your area and your LoRaWAN device can send messages to that gateway. In tutorial 21, I have explained the difference between over-the-air activation and activation-by-personalisation. In the activation-by-personalisation method, the end device must store the device address, application session key, and a network session key. The network server must store the same device address and network session key. Go to the Things network, log in, select Console, click on Applications, select the YouTube demo application, and register a new device. Enter a unique identifier, for example, YouTube_demo_device2. Enter a device AUI. It is a random value consisting of 8 bytes. I use my online tool. Press the Generate button. Copy the last 2 blocks. The code is pasted in this field. As you can see, it is 8 bytes long. Press the Register button. In this screen, select Settings. Change the activation method to ABP. As you can see, the device address will be assigned by the network server, the network session key will be generated, and the application session key will be generated. Press the Save button. These 3 values must be stored in the end device. The device address must be in a hexadecimal format. The network session key must be in big endian format as a 16 bytes array. Click this button. 16 bytes array, big endian format. The same applies to the application session key. Big endian format, 16 bytes array. These 3 values needs to be copied to our new Arduino sketch, which I will explain in a moment. In the Arduino IDE, select Menu, File, Examples, MCCI LoRaWAN LMIC library, and select the sketch ttn-abp. And resave this sketch. Save it as ttn-abp my demo. Copy the network session key, application session key, and the device address from the Things console to this sketch. As you can see, I have copied the 3 values from the Things console to this sketch. These 2 values must be in big endian format, and the device address must be a hexadecimal value and not an array. Prefix it with 0x to indicate that this is a hexadecimal value. Same as in tutorial 22, the message Hello World is transmitted every 60 seconds. If we use this transmit time interval, we will not comply with the Things network fair access policy. If we run the sketch for more than 24 hours and the data rate is spreading factor 7, bandwidth 125 kHz, or even worse, spreading factor 12, bandwidth 125 kHz. Please do the calculations yourself. Make the same pin mapping changes as explained in tutorial 22. Slave select is 10, reset is 5, DIO 0 must be 2, DIO 1 must be 3, and DIO 2 must be unused. Comment out these lines. Now connect the self-built LoRa development board to your computer using the USB cable. Now select the correct board. Select Menu, Tools, Board, Arduino Uno, and select the correct port. Select Menu, Tools, Port, this port. Compile this sketch. As you can see, there are no errors. Now upload this sketch to the Arduino Uno. As you can see, there are no errors. Open the serial monitor. and set the baud rate to 115,200 baud. Go to the Things Network console, select the app YouTube Demo App, select the registered device, YouTube_demo_device2, select Reset Frame Counters, and select Data. As you can see, the message Hello World is received by a gateway and sent to the network server and displayed in the Things Network console. Please note, there is no join request message sent. As you can see, every 1 minute the message Hello World is sent. As you can see, we are using the Application-By-Personalisation activation method. Thanks for watching. I hope you enjoyed the video. Please hit the like button and don't forget to subscribe. If you have questions, leave your comments below. I'll do my best to answer them.